Hello, Honors Algebra 2 students. We're winding down on all the lessons that you'll be needing. I think there's only one more after this. So this is 13-2, day 2, defining general angles and using radian measure. Now, what is a radian? Well, a radian is the measure of an angle in standard position where, I need a little bit more room, it cuts an arc. It cuts an arc that is the same size as the radius. And what I mean by that is, if I were to take a unit circle, that's a circle that has, well, we'll talk about that in a second. So there's our circle. Now, what is a radian? Well, a radian is, if you were to take the radius, take this radius right here, and if it were a string and you were to lay it along the outside of here, this arc length is R, and it is the same exact length as the radius here, or here, the radius anywhere on the circle. So if you were to take a string the length of the radius and lay it on the outside of the circle and then end it, this is 1 radian. 1 radian. Okay, so let's figure out, we have degrees and we have radians. Those are the two ways that we measure angles. So if we want to see a conversion that goes from degrees, and I'm just going to write that as DEG, to radians, we have a conversion factor of what we have to do. So you would take the angle that you know measured in degrees and multiply it by pi radians, I forgot my R, pi radians per 180 degrees. To go all the way around this circle, you would go 2 pi radians. That's how many radians there would be in the whole circle. Or in other words, if you were to take 2 times 3.14 times the radius, you would get the entire circumference of the circle. Okay, so now if we're going to go from radians to degrees, we're going to do the opposite of that. We're going to take however many pi radians we have, and it'll be in pi radians, and we're going to multiply that by 180 degrees per pi radians. If there's 2 pi radians in a circle, all the way around 360, then there's 1 pi radian or 180 degrees. So that's where we get those conversion factors. Sorry about that, we kind of went off the paper. All right, now we can do the conversion. They want us to convert 125 degrees to pi radians. So the first thing you do is write the 125 degrees. And then you have to figure out we are going from degrees to radians. We're going to use this one. So this would be the place of the 125. Pi radians divided by 180. Now, you put this in your calculator and get the fraction. Don't use decimals on these. We put them in fraction form. So if we were to do this, we would get 25 pi over 36 radians. 25 pi over 36. 36, my table's kind of funny. Radians. And that's the answer to that. Okay, now this one I don't have. We're going to go radians degrees, and it's not written down here. It's negative pi over 12. We want to figure out how many degrees would negative pi over 12 be. So we start off with a negative pi over 12 radians. And we multiply that by 180 degrees divided by pi radians. These guys cancel, leaving us with negative 180 divided by 12, which is negative 15 degrees. So we went each way with that. All right, let's do this one. Number 3, degrees to radians. Degrees to radians, 135 degrees times pi radians over 180. Now take the 135 divided by 180 and then put it and convert it in your calculator to fraction. That is going to give us 3 pi over 4 radians. So 135 is 3 pi over 4 radians. Negative 50 degrees, you're going to start off with a negative 50 times pi radians divided by 180 degrees. And when you reduce that, what you're going to get is negative 5 over 18 pi radians. Number 5 is not written there. 5 pi over 4 is what we want to do. So we start off with a 5 pi over 4. This is what we're starting with. And we are going to multiply that. I'm going to put radians here. And we're going to multiply that by 180 degrees over pi radians. The pi radians cancel, and we have 5 times 180 divided by 4, which is 225 degrees. So 5 pi over 4 is this in radians is the same as saying 225. They mean the same exact thing. There are 2 different ways to show it. Number 6, that should be pi over 10. And we are going to convert that by taking 180 degrees divided by pi radians. Pi's cancel out, and we have 180 divided by 10 is 18 degrees. Now we aren't going to do this. So that's really not part of anything we're going to do. So this is shorter than what you thought, but I want to talk to you about a unit circle quickly. Now here I have a unit circle, which means that this point right here is, unit means 1 in this case. So this point would be considered to be 1, 0 over 1 up 0. This one would be 0, 1. This one is negative 1, 0. And this one is 0, negative 1. So it's a unit circle. The radius is 1. Now when we're talking about, this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this on the other side of it would be 360. I should have put the 0 up there. All right. Now there are special angles that we usually take into consideration, and they are 30 degrees. You'll find this when you do the trig. 45. And 60. This is not drawn to scale, clearly. And then you would go 30, and then you'd go to the 45, and then you'd go 30 away from that one. But we're going to stick with the first quadrant. What I want you to understand is that you will see this 2 different ways. You will see this as 2 pi radians for this one. 2 pi. This one will be pi over 6. This one will be pi over 4. This one would be pi over 3. If you did the conversions, you would find that to be true. And then this one would be pi over 2. And if you did them, you would be able to convert all the rest of these. This would be pi. and this is 3 pi over 2. And then that would be 2 pi, or 4 pi over 2. So this is what a unit circle would look like, and you're going to be using the different types. You'll be using 30 or pi over 6. You'll be doing all kinds of fun stuff like that when you get to trig. But I just wanted to make you familiar with that. And we will probably talk a little bit about this when you take honors physics, just to get you used to using angles. Well, I hope everybody's doing well. Take care.